looking at 2A.2, math to the new objective, which says I can write the ratio for sine, cosine, and tangent using the Pythagorean theorem to calculate the missing side. So, for these problems, all right, we now have to use Pythagorean's theorem. This should be a review, right? Where Pythagorean's theorem says the sum of the squares of the legs is equal to the square of the hypotenuse. So again, the sum of the squares of, that should say the legs, that's fine, of legs is equal to the square of the hypotenuse. Another way of saying this is, right, it's the sum, so we know we're adding squares of the legs. Well here, right, this is a leg, and this is a leg. Right, so that's a and b, and I'm squaring them. So a squared and b squared equals the square of the hypotenuse. Right, and c is our hypotenuse. So Pythagorean's theorem is really just a squared plus b squared equals c squared. You should have seen this before. It was also one of the things we did on that very first activity where I made you look at notes without really knowing what you were doing. So you have also done these problems before with those. All right, so let's look at some examples. So the first thing I like to do is identify the legs and the hypotenuse. So leg, hypotenuse. Right, because that one's across from the right angle. Okay. So now, when I plug in, I know these are A and B. It doesn't matter which one's which. They can flip, remember, because addition is commutative. So I have 8 squared plus 15 squared equals C is just x squared. So I'm actually going to square my numbers. 64 plus 225. And if you need to use a calculator to square those, that's fine. Feel free. So then 64 plus 225 is 289. I don't know why I'm getting ahead of myself. 289 equals x squared. Then I can take the square root, and x equals, and the square root of 289 is 17. Okay, and you can, like I said, you can always use a calculator to do those. Right, your square root on these calculators is right up here. It's usually also above the x squared button on the little calculators. All right, so 17. All right, let's look at our second one. So this is a leg. So I have a squared plus b squared equals c squared. So that's a leg, so x squared. My other leg is 8 squared. So I have x squared plus 64. 20 squared is 400. I'm going to subtract 64 from both sides. 400 minus 64 is 336. $336, yes. Come on. So now when I take the square root of that, you will see that you'll get a decimal. Now, with what we are going to be doing, we do not want decimals. We want exact answers. So I need to find a perfect square that goes into 336. So I'm going to just write, remember your perfect squares. I'll write it over here really quick. Right, we don't really worry about 1, but 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 6 squared equals 36, blah, 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 blah. For some reason I skipped 5. 5 squared equals 25, right, so on and so forth. I like to start just by dividing by these, seeing if I get anything. So I could do 336 divided by 4. And I get 84. So I'm going to rewrite this. I know a 4 goes into it. Well, now I have 84. It looks like something can go into that. So again, 4 probably. 21. 21, we have to start recognizing 21. The only things that go into 21 are 3 and 7. There's no perfect square in it. So we call it prime. So you do want to start recognizing those prime numbers, okay? So now the square root of 4 is 2, so it pops out. The square root of 4 is 2. 21 doesn't have a square root. 2 times 2 is 4, root 21. Okay, so we do have to start simplifying these square roots. Okay, and we'll see more examples as we go on with these problems. Let's look at example 3. Okay, here's my right angle, so my hypotenuse. I'm going to put an X there. This is a leg. This is a leg. So a squared plus b squared equals c squared. 4 squared plus 8 squared equals x squared. 4 squared is 16. Add those up, I get 80. Square root x equals, again, I'm going to start breaking this up. I like starting with 4, especially if we have even numbers. It makes the most sense to me. If you see another number that divides into it, that's fine, but 80 divided by 4 is 20, so 4 does go into 80, so that is one perfect square. I think we can also see then that 20 is 4 times 5, right? 4 times 4 times 5 does give me 80, and I can take the square roots of some of these things. The square root of 4 is 2, 2, I cannot take the square root of 5, so I get 4 root 5. It won't always be a 4 on the outside, but these just both happen to be. Okay. All right, so how does this relate to what we're doing with our sine, our cosine, and our tangent? So looking at example 4, right, find the cosine of angle A. So here's angle A. So I have my hypotenuse, the opposite, and the adjacent side. So cosine of A equals adjacent over hypotenuse. Remember using, I'll just write it down here real quick. So Katoa. So cosine of A equals 8 over 10, which is 4 out of 5. Nice, easy question, just like we did yesterday. Now, in example number 5, I want to find the sine of angle A. Hypotenuse, opposite, adjacent, relabel our sides. So sine of A is opposite over hypotenuse, which equals, I don't know my opposite side, I only know my hypotenuse. So now, in order to find the sine, I need to find that missing side using Pythagorean's theorem. Okay. So I usually say my A, adjacent side is A, My opposite side is b, but again, it doesn't really matter. So we'll call that x and 10 squared. Okay, these are just my two legs, so as long as they go on this side, then you should be fine. The board jumps around. Okay. So I have 8 squared plus x squared equals 10 squared. 8 squared is 64. 10 squared is 100. I'm going to subtract 64 from both sides. So x squared equals 36. Take the square root, x equals 6. So that's 6 over 10. Reduce that, you get 3 over 5. Okay. So let's look at some more different examples that we might see. Example number 6, find the cosine of A. So, here's my right angle, it's not in there. I have my hypotenuse, my opposite, and my adjacent. So cosine of A equals adjacent over hypotenuse, which equals 5 over length. So a squared plus b squared equals c squared. 5 squared plus 12 squared equals x squared. 25 plus 144. So that is 169. Take the square root, x equals 13. Okay. So that goes in my blank. That does not reduce. The cosine of A is 5 over 13. Okay. For C, find the tangent of A. Okay. So we have our hypotenuse, our opposite, and our adjacent. Tangent equals O over A, which equals blank over 6. So A squared plus B squared equals C squared. So I have 6 squared plus x squared equals 9 squared. 36 plus x squared equals 81. I'm going to subtract both sides by 36. X squared equals 81. I should know this, but that's okay. 81. 81 minus 36 is 45. Looking at this, when I take the square root, you should see that x equals, right, 45 is 9 times 5. I can take the square root of 9, that's 3 square root 5. Okay. So that goes in my blank. This does reduce, right? 3 over 6 becomes 1 over 2. So we can say 1 square root 5 over 2, or just square root 5 over 2. I don't necessarily need that 1 there. Right? It's kind of like writing x or 1x, right? I don't need the coefficient of 1. So square root 5 over 2. All right, looking at 8, our last set of problems. Here it just tells us given tangent theta equals 5 over 12, find sine of theta. So the first thing I'm going to do for these problems is draw a triangle. Okay. I can put theta anywhere I want. I'm going to put it here. I do need a right angle though. Okay. I am going to start by labeling my sides. Opposite, adjacent. And now, I need to use my given information. Tangent of theta. Tangent is your opposite over your adjacent. So this tells me my opposite side equals 5, and my adjacent side equals 12. I then want to find sine of theta, which equals opposite over hypotenuse, which equals, well, we know 5 over something, right? So I have 5 squared plus 12 squared equals x squared. 25 plus 144, 169 equals x squared square root, x equals 13. Okay, so it's very similar to what we did above. You just have to kind of draw your own triangle and put in your first two sides. So let's do the same thing with number 9. Cosine of theta equals 3 over 5. Opposite and my adjacent side. So cosine of theta which equals adjacent over hypotenuse. So I know my adjacent side is 3 and my hypotenuse is 5, right? That's what that tells me. So then doing our Pythagorean's theorem, A is 3. I don't know my opposite side. Right, so that's 9 plus x squared equals 25. (25 minus 9 is 16. X equals 4. Okay, so for the sine of theta, opposite over hypotenuse, which is 4 over 5. Alright, sorry for the somewhat longer video, but we wanted to make sure we got all of that, and we will practice tomorrow. Have a good rest of your day.